NEET 2025 aspirants. So today we are going to solve the solutions of mock test 1 chemistry. Okay, so I hope all of you have attempted the question paper, and please first attempt the question paper and then see the solution, otherwise there is no point of practicing, right? So let's get started with the first question here. The polarity of the covalent bond among the following is maximum in. Now if you see the polarity of the covalent bond, okay, so polarity depends on the charge, right? So if I have, for example, one element is there and this is another element, if the electronegativity difference between the two elements is high, then the polarity will also be maximum, right? So here you can see these are the same elements, so no electronegativity difference. Oxygen and fluorine both are electronegative elements, so that is why their electronegativity difference is less. Same here, but in C and F, you know, fluorine is highly electronegative as compared to carbon, so there is a more electronegative difference, and that is why the bond is maximum polar here. Okay. Next, the lysine extract is boiled with concentrated HNO3 while testing for halogens. By doing so, so when we boil this lysine test, we get rid of this Na2S and NaCN if it is formed. Okay, so that is why option number A here. Next, the wavelength of the photon obtained by the electron transition between two levels in H atom and singly ionized He are lambda 1 and lambda 2 respectively then. Okay, so first let us calculate for hydrogen. Okay, so we know what is the formula, minus 13.6 Z square by 1 by N1 square minus 1 by N2 square, right? Now here I can write minus 13.6 Z square is 1, okay. Two levels, you can take ground level and the second level. So 1 by 1 square minus 1 by 2 square. So that will give me minus 13.6 into 1 into 3 by 4, okay. So this is the value of 1 by lambda 1. Okay, 1 by lambda 1 is this one. Now 1 by lambda 2, if I want to calculate, what is that value? Minus 13.6. Now this is for helium. Okay, I am doing for helium. Minus 13.6 Z square, hydrogen helium, Z square is 4. Okay, and same 1 by 2 in this one will give me 3 by 4. Okay, now if I just take a ratio of this one, 1 by lambda 1 divided by 1 by lambda 2, that will be equal to lambda 2 by lambda 1. Okay, so next let's just write down what is lambda 1, minus 13.6 1 into 3 by 4. Okay, and then lambda 2, okay, so 1 by lambda 1 divided by 1 by lambda 2, so I will just write down this one here, minus 13.6 into 4 into 3 divided by 4. Okay, so now I can just cancel the minus 13.6, then 4, 4, 3, 3. Okay, so what I will get, lambda 2 by lambda 1 is equal to 1 by 4, or I can write down lambda 2 is equal to lambda 1 by 4, which is option number D here. Okay. Next, question number 4 here, A and B. So you have to be very careful here. A is on that side and B is on this side. Now if I see A, you have to first add water here in CH3. Okay, C triple bond CH. First I will add water, okay, in presence of Hg2 plus. So what will happen? Water will be added following anti-Markovnikov's rule. Okay, so I will get here OH, following Markovnikov's rule, and I will get this one. Now what will happen? Tautomerization will take place and you will get CH3COCH3. Okay, this one will give you acetone. So A is acetone. I have all these three options. This one I can eliminate. Next you see this one, you are adding BH3, THF, H2O2. See, this adds water following anti-Markovnikov's rule. So what is B here? I will get CH3, C double bond C, OH, H. Okay, next CH3, C double bond C, COH and H. Now if you just what I'll say, H2O2 and OH minus, so if you just cover it or if you just undergo tautomerization, then what will happen? You will get CH3COH. Okay, Now you can see this is acetone and this is your aldehyde. So that one will be, okay, just a minute. Okay, I left one more carbon here. So you will get A will be CH3COCH3 and B will be CH3CH2COH. So that is why option number B here. Okay. Next, the set representing the correct order of ionic radius. So if you see, I have lithium, sodium, okay, and then beryllium and magnesium, right? Lithium, sodium, beryllium, magnesium. The set representing the correct order of ionic radius. So we know that along the period the size decreases. So definitely Na plus will have the maximum size and lithium plus will have the next one, because these are +1 charges and these are +2 charges. So after that magnesium and then beryllium. So option number A here. Next, oxidation state, oxidation of 1-butene with hot KMnO4 solution will produce. So if I have but1-ene, that is CH2 CH double bond CH2, and if with OH and this one, what will happen? CH3 CH2 CHOH and CH2OH. Okay, now what will happen? This will break and I will get CH3 CH2 COOH and HCOOH. Okay, so I will get one acetic acid and formic acid. That is option number A here. Next, the volume of methane evolved by the treatment of 16.6 gram of methyl magnesium iodide with water at STP. So if I see this one, I have volume of methane evolved by the treatment. So first let me write down the reaction: methyl magnesium iodide, okay, plus water. That will give me CH4 plus MgIOH. Okay, now if you see, this reaction is already balanced, and what is the molar mass of CH3MgI? Molar mass of CH3MgI. Okay, so that is your 12, carbon is 12 here, right? Hydrogen is 4, magnesium is 24 and iodine is 127, right? Now just if I add this one, 7 plus 4, 11, 11 plus 11 plus 4 is 15, 16, 17, 1. Okay, this iodine mass is, one second, just let me check. Carbon is 12, hydrogen is 3, right? Not 4, because 3 hydrogens are there. So this one will be 3. Okay, so I will get 166. Okay, so if you just add these 3, you will get 166. So what is the number of moles of CH3MgI? Given mass by molar mass, 16.6 by 166, right? So that is 0.1. Right, number of moles is 0.1. So if I have the volume of methane evolved by 16.6 gram of methyl magnesium iodide. So if this is 16.6 gram of methyl magnesium iodide, then this one will be 1 mole and this one will also be 0.1 mole, right? So 0.1 mole of methane will be formed. Now what is the molar mass of this, what is the volume of CH4 created? So you know that 1 mole occupies how much volume? 22.4. So 0.1 mole will occupy 2.24, right? So that is why option number B. Next, the heat of combustion of ethanol determined in a bomb calorimeter is minus 670.48 kilocalorie mole inverse at 25 degrees Celsius. The what is the delta H for the given reaction? Okay, so you know heat of combustion of ethanol. So if I just want to do the combustion of ethanol, it will give me C2H6. First of all, I'll get CO2. Okay, I will get CO2 plus H2O. Now let us balance it. I have 2 carbon. Okay, I have 6 hydrogen. Okay, next I have 7. So here it is 3. 3 to the 6 plus 1, 7 oxygen is there. Now what we have here, delta H is equal to delta U plus delta NgRT, right? Now delta U value is how much? Minus 670.48 plus, what is delta Ng value? 3 plus, I have to take only the gaseous molecules, right? So this is again liquid and this is also liquid. This is gas and this is carbon dioxide is gas. So 2 minus 3 is minus 1. So delta Ng is minus 1. R value, you know, it is in calories. So R value will be 2 into 10 to the power of minus 3 and temperature is 298. Okay. So I will get minus 670.48 minus 2 8s are 16, 2 9s are 2 8s are 16, 2 9s are 18 plus 1 19, 2 2s are 4 plus 1 5, and we have this one 0.596. So 670 plus something in negative, right? So that will be 671. Right? You can just add this. You can see this one definitely will not be there. Plus is not there. This is also not there. So it will be minus 671.08. Now fixed volume of 0.1 m benzoic acid solution is added into 0.2 m sodium benzoate solution. So you can see a weak acid and a salt of weak acid, right? And they formed a 300 ml solution. The total volume is 300 ml. Resultant acidic buffer solution. If the pH of this buffer solution is 4.5, then find the volume of benzoic acid added. Okay. So first of all, let us calculate the number of moles of benzoic acid. Now see, I am just writing Ba for benzoic acid. You know, molarity is given and volume is fixed. So let's take the volume as X. So what is the number of mole of benzoic acid? 0.1 X. And if I just want to calculate the concentration of benzoic acid, that is C6H5COONA. Sorry, C6H5COOH. So that will be 0.1 X divided by 300. Why? Because the total volume is 300. Now similarly, number of moles of salt of benzoic acid. That is what you can see here. It is 0.2 m and the volume will be, if this is X, the volume of the other one will be 300 minus X. So 0.2 into 300 minus X. Okay. And then salt of benzoic acid C6H5COONA, that will be equal to how much? 0.2 into 300 minus X divided by 300. Okay. So this we got concentration of both. Now we have what? pH is equal to pKa plus log of salt concentration by acid concentration. Okay. Now pH is equal to 4.5, that is equal to 4.2 plus log of, what is salt concentration? 0.2 into 300 minus X, right, divided by 300. So that 300 and this 300 will get cancelled. So this one will be 0.1 X. Okay. Now this one will 0.3, that is equal to log of 0.2 into 300 minus X divided by 0.1 X. Now this is 10 to the power of 0.32 log of 0.2 into 300 minus X divided by 0.1 X. This log will go now, right? So that is not there. Okay. So now what I can do, just you can multiply this one. So 0.2 X is equal to 60 minus 0.2 X, right? This one will add this side. So 0.4 X is equal to 60, X will be equal to 150 ml. Okay. So that is option number B here. Next, question number 10, which one of the following statement of quantum numbers is false? So quantum numbers were proposed out of the necessity in Bohr model of the atom. Yes, that is the correct statement. Knowing N and L, it is possible to designate a subshell. Yes, 2p, 3s, these are all subshells, we can designate them. The principal quantum number alone can give the complete energy of an electron in any orbit. No, the complete energy is given by N plus L. Okay, so we need both quantum number, principal quantum number and azimuthal quantum number. So this is the wrong statement. Next, which of the following complex shows geometrical isomerism? So for geometrical isomerism, here all the ligands are same, here also, here also. So these all will not show. Here we have two types of ligands, so they can show you both cis and trans geometry. Next, given nitrogen compound containing aromatic A given nitrogen containing aromatic compound A reacts with SnHCl followed by HNO2 to give an unstable compound B. So you can guess that SnHCl, if we have NO2, that gets converted to NH2, and once you treat it with nitrous acid, that gets converted to N2 plus and Cl minus, which is unstable. B on treatment, that is B will be your benzene diazonium chloride. B on treatment with phenol. So I have B, this one, okay, N2 plus and Cl minus, and if I treat it with phenol, so what I will get? I will get a compound like this, N double bond N, I have phenol, and then I have OH group. Okay, so this is there, and this is your beautiful colored compound. You know, these are azo dyes, they are colorful compounds. So what is the structure of compound A? That is option number D here. Let's see the next question here. Experimentally, it was found that a metal oxide has M0. So this is actually in this form, M0.980. Okay, and the metal M is present in two forms, +2 and +3. Okay, so fine. We have to find the percentage of M plus 3. Okay, so total it is this was 0.98. Okay, let's convert it into percentage, or I can say that it is 98, because if the total mass is 100, then this is, let me just take that 100 moles of this one is present, right? In 1 mole it is 0.98, so in 100 moles it will be 98. And what is the total charge? Total N negative charge. Total negative charge will be 100 into oxygen charge is -2, so 200, and that will be equal to N total positive charge, right? Total positive charge will be equal to total negative charge. So I can now write down this M3 plus, let it be in the form of X, and M2 plus then will be in the form of 98 minus X. So if I just calculate 3x plus 2 into 98 minus X, that is equal to 200. So you can just multiply 3x plus 196 minus 2x is equal to 200, and X is equal to 4. Okay, so I have X is equal to 4 here. Now what is the percentage of M3 plus, because you have to calculate in the form of percentage. So 4 by 98 into 100, so it will be nearly equal to 4, right? You can just convert it into 100, we can cancel. So option number B here. Next, Fe3 plus compounds are more stable than Fe2 plus. All we know that they have D5 configuration, so that is why option number B here. Next, which is the correct order for the acidic strength of the following compound? So you know, electron withdrawing groups are there, that means they will be more acidic, right? So option number, I can see here that here a electron withdrawing group is there, so 2 will be more acidic. I can eliminate these two options. Next, after that you see I have 4th here, which is also an electron withdrawing group. So in both the options I have 4 after that. Next you see OCH3 and OCH3. Now OCH3 at para position is an electron donating group, but OCH3 at meta position is an electron withdrawing group by -I effect, right? So this is also having a withdrawing effect, it doesn't have +R effect. So after that 3 will come, so that is your this one, and then we have phenol, and then we have OCH3, so that is why option number D here. Next, we have to find the product A and C. So here what is there? There will be H plus and heat. You will have elimination reaction, and we will get a more substituted alkene is formed according to Sedzeff rule. So bond will form here. So that is option here I can get. Here I am not getting. Here also. Okay, just a minute. Yes, this can be there. This is not there, right? We need a more substituted alkene. So it can be either B or C. Next, you are adding HBr in the absence of peroxide. So if I add HBr to this one, bromine will attack here. So here bromine is not attacking. Why? Because of Markovnikov's rule, right? So that is why option number B. Next, 2 liters of N2 at 0 degrees Celsius and 5 atm are expanded isothermally. So I have what? 2 liter of N2 is present, which is at 5 atm. Okay, is expanded isothermally against a constant external pressure of 1 atm. So what is constant external pressure? That is equal to 1 atm. Next, until the pressure of the gas reaches 1 atm. So now this pressure reaches to 1 atm. Okay, and assuming the gas to be ideal, calculate the work of expansion. So we have this formula P1 V1 equal to P2 V2. So I already have initial volume of N2, I need to calculate the final volume. So I have P1 V1 by P2 is equal to V2. P1 is equal to how much? 5 atm, and V1 is equal to 2 and P2 is 1. So V equal to 10 liters. Okay. 10 liters. Now I want to calculate the work done, that is equal to minus P external V2 minus V1. Okay. So minus what is external pressure? 1 atm. V2 is your 10 minus 2, that is 8 liter atm, and equal to 101.35 multiply 800 something we will get minus, that is because of expansion. So option number D. Next, the rate of first order reaction is given. So what is rate value? 1.5 into 10 to the power of minus 2, and the concentration value is 0.5 molar. What is K then? K will be equal to rate by concentration. So 1.5 into 10 to the power of minus 2 divided by 0.5. So that is 3 into 10 to the power of minus 2. That is the value of K. Now what is T half? T half formula is 0.693 by K. That is 3 into 10 to the power of minus 2. So that is 69.3 divided by 3. It will be 13.1 something. 23.1. So that is why option number C here. Next, you have to arrange them in the basic strength. So we know that basic order, these amines, aromatic amines are least basic because their nitrogen is involved in resonance. So one will be least, so I can eliminate these two options. Next, what I can see, after 1, 4 is there in both the option. Between 2 and 3 I have to decide. So 2 is your secondary and 3 is your tertiary, right? And we know that secondary amines in any medium, 2, 1, 3, it comes in the aqueous medium. Secondary is more, so that is why option number A here. And next, many of the lanthanides ions are colored in the solid state as well as in the solution. The color is due to, so the color is due to excitation 4F, 5F, no, 4F, 5D, no, 5D, 4F, no, 4F, 4F, yes, that is option number D here. Okay. Which of the following alcohols gives a red color in Victor-Meyer test? So in Victor-Meyer test, if you know, we have primary alcohols, they give that, so that is why N-propyl alcohol, option number A. Okay. Next, a carbonyl compound gives pink color with Skiff's reagent and a yellow precipitate when boiled with iodine and caustic alkali. So yellow precipitate it is giving means it will have this CH3CO group must be present in that, right? It gives a red precipitate with Felling's test, that means it must be one aldehyde group. So we need an aldehyde group which is having this CH3CO group. Formaldehyde doesn't have this group. Propion aldehyde doesn't have this group. Croton aldehyde, if you know the structure, it is like this. This is the structure of croton aldehyde. Here also this group is not present, so only answer is acetaldehyde. Next, the three structures are given below in which two glucose units are linked with each of this. What is the linkage you have to find out? Okay, so in A I can see 1, 2, 3, 4 and this one is this is 1, 2, 3, 4 and this is first carbon. So it is C1, C4 here, and here it is 1 and 1, 2, 3, 4, 5, 6. So that is C1, C6, and here we have 1, 2, 3, 4. It is C1, C4. So I have A and C in the C1, C4 structure. Okay. So A and C are between C1, C4 and B is C1, C6. So option number C. Next, the following compounds are. So let us just take R and S configuration. So this is 1, this is 2 and this is 3. So if I move like this, it is getting clockwise R, but H is not in the vertical position, so this will be S isomer. Here if I see 1, 2 and then 3, so this is your clockwise direction, so this is R. R and S configuration means they are enantiomers. Next, the density of a 2.05 molar solution of acetic acid in water is given. The molality of the solution is. Okay. So now if I just calculate density, right? Density is how much? 2.05. What is the volume of the solution? Molarity is given means 1000 ml, or I can say 1 liter. The density is 1.02. Okay. Then what is the mass of the solution? 1020. Okay. Next, this is mass of the solution. Next, what is the mass of the solute here? You can see I have taken 2.05 moles of acetic acid. Acetic mass is 60. Acetic acid mass is 60. So 2 6 are, or sorry, 6 5s are 30. Just let us calculate this one. So I will get 6 5s are 30, 0, 6 2s are 12, this one. So I will have 123. So what is the mass of the solvent? Mass of the solvent will be 1020 minus 123. So that is 10 minus 3, 7. Okay. 1020 into 123, 10 minus 3, 7, then 1, and I will get, sorry, 6, and here I will get 8. Just a minute, I have done wrong calculation here. Sorry, 1 second. Yes, so I have to subtract 1020 minus 123. Okay, so 10 minus 3 is 7, then I have 1, so I'll again carry 11 minus 2 is 9, here 9 minus 1 is 8. Okay, so I will get 897. This is the mass of the solvent. Now let us calculate the molality. Molality will be equal to what? Number of moles of solute, which is already 2.05 into 1000, okay, divided by this one 897, that is the mass of the solvent. Now I can write it as 2.05 into 1000 by 900, okay, just for easy calculation. So I can get 2050, okay, divided by 9. So you can see 9 2s are 18, so it will start, yes, so it is actually 2.28, this option is 2.28, so 9 2s are 18, then we will get this one as, so it is 20.5, okay, 20.5 divided by 9, so 9 2s are 18, so that is why option number C here. Now let us see the next question here. H3PO4 is a tribasic acid and one of its salt is NaH2PO4. What volume of 1 molar NaOH should be added to 12 gram of NaH2PO4 to convert it into Na3PO4? Now this question might seem very difficult in terms of language, but if you see, understand it very carefully. So what basically you have to do is you have to convert, just a minute. Yes, so what I am doing is this H2 is removed and we are getting Na3PO4, right? So what I can say that number of moles from this one, right, from this particular compound I'll get 2H plus, right? So number of moles of this one will be like neutralized by number of moles of NaOH. So I can say that number of moles of H plus, this is coming from NaH2PO4, okay, should be equal to number of moles of OH minus according to neutralization reaction. Now if I want to convert number of moles of H to PO4 means number of moles of H plus, so given mass by molar mass into 2. Why? Because I have 2H plus from each mole of NaH2PO4, I'll get 2H plus. So what is the number of moles of H plus? So I have given mass, that is 12, divided by molar mass. So here if I just want to calculate the molar mass, 23 plus 2 plus 31 plus 64, right? 3 2 5 plus 1 6 plus 1 10. So I will get 6 plus 3 9 10 11 12 120, okay, 120 into 2. This is what? Number of moles of H plus. That will be equal to number of moles of OH minus. Now what is number of moles of OH minus? You can see molarity is given and we know that number of moles is equal to molarity into volume. So I have been given with molarity, so M into V, so 1 into V, okay. Now we can solve this. So 12 ones are 12 tens are 0.2 is equal to V in liters. Now if I just want to convert it into ml, so 200 ml. So that is why option number B here. Next, 10,800 coulomb of electricity through the electrolyte deposited 2.977 gram of the metal with atomic mass 106.4 gram per mole. The charge on the metal cation is. So suppose we have any metal Mn plus, okay, plus n electron will give me metal, right? So I can use Faraday's law and I can write M is equal to molar mass divided by N into 96500 into I into T, right? So here what is there? 2.977, okay, is equal to what is the molar mass here we have? Molar mass is, we have to calculate, that is 106.4, okay. N value I will calculate, then 96500 into 10,800, okay. So this one I can cancel. Next I can write N, I have to find out. So 106.4 into 108 divided by 2.977 into 965. Okay. Now how I can round it off and do the calculation. So just let me make this as 105. Okay, and this one let me keep it as 108. This one let me make it 960, and this one let it make me 3. Okay, so now if I see 3 3s are 9, 36. Okay, now 36, 6 6 are 36, 6 16s are 160. I got. Next I can cancel 5 2s are 10, 5 21s are, 5 3s are 15, 1 5 32. Next 2 3s are 6, 2 16s are 32, right? So I have now 21 into 3 divided by 16. Okay, so I can say it will be any other calculation I can do here. No, right? So 3 1s are 3, 3 2s are 6 and 16, right? And if I know 16 4s are 64, so it will be somewhere near to 4. So that is why, or I can just divide 16, right? I will get 16 3s are 48. Okay, 13 minus 8 will be 5, 15, then 1, then I have to definitely go 9 6 are 54. 1 9 6 are 54, 9 1s are 6 plus 1. So 3.8 something I will get, which is nearly equal to plus 4. So that is why option number A here. Next, HCOH on heating with concentrated sulfuric acid. This gives you carbon monoxide. So option number B. Next, what will be the change in internal energy? Okay, so we know delta U is equal to Q plus W. Change in internal energy when 12 kilojoule of work is done on the system. So work, this is 12, and you have 2 kilojoule of heat is given by the system. So minus 2. So that will give me 10. Option number A here. Okay. Next we have the specific conductance of a salt is given. So kappa value is given to me as 1.06 into 10 to the power of minus 4, and concentration is given to me as 10 to the power of minus 2, and then we have to calculate molar conductance. Okay, it is kappa into 1000 by C. So kappa value will be 1.06 into 10 to the power of minus 4 into 10 to the power of 3 divided by 10 to the power of minus 2. Okay, so I will get this one 10.6, that is option number C. Next, the degree of hydrolysis of which of the following salt is independent of the concentration of the salt solution. So you know, in this strong electrolyte, strong salt of a strong acid and a strong base does not undergo hydrolysis, so it doesn't depend. That is why option number D. Next, the correct order of the bond angles in the following. So if I just see the structure and the hybridization, so I can see that in NO2 plus, so I have what all species? NO2 plus, NO2 minus and NO2. Okay, so now if I see here, NO2 plus means the structure will be somewhere around like this, and it will have sp hybridization. Now NO2 minus, so it has 5 electrons, total 6 electrons are there, so it will have like this, and that will be your again sp2 hybridization. NO2 will have 5 electrons, 1 2, so I have like this. The structure of NO2 is like this, right? So in this what happens again, there is what we will get, sp2 hybridization. Okay, so NO2 structure, if I see, it is like this. Okay, so now you can see here, this is also sp2, this is also sp2, so definitely NO2 plus will have higher bond angle, so I can eliminate these two. Okay, now here you can see there is a lone pair. In which one? In NO2 minus there is a lone pair, so the bond angle here will decrease. Okay, because of repulsion this bond angle will decrease, so NO2 minus will be having the least one, so option number D here. Next, the IUPAC name is given, you have to identify the IUPAC name. So we have amine, aqua and bromo. So bromo will not start at the starting because we have to follow alphabetical order. So definitely tetra, amine, aqua, bromido, cobalt 3 nitrate, option number D here. Next we have which of the following is a non-reducing sugar. So if I have non-reducing sugar, you should not have this group. Okay, if this group is present, Okay, if this group is present, then it will be a reducing sugar. If this group is not present, then it is a non-reducing sugar. Now if I want to see here this carbon, okay, so it has OH and OR, so this group will have reducing sugar. Here if I see OH and OR, reducing sugar. Here also I can see OH, OR, reducing sugar. Here if you see, here this side it is O and this side it is C, and here also I don't have O and this side also it is O. So I cannot find OH, OR group attached to the same carbon. So definitely this is your non-reducing sugar, which is option number B. Next, the number of chiral centers in the open chain structure of glucose. So you have CH, then CHOH is present, right, 4 times, then CH2OH. So all these 4 carbons present in between are chiral because they have different groups attached. So that is why option number B. Next, in aqueous solution of EU2 plus acts as. Now EU2 plus, okay, is a stable one, but the common oxidation state is EU plus 3. So it can undergo oxidation, and that is why it will behave as a reducing agent, option number B here. Next, the vapor pressure of pure benzene and toluene. So you have vapor pressure of pure benzene and toluene, okay, so that is 160 and 60, okay. The mole fraction of toluene in vapor phase in contact with the equimolar solution of benzene and toluene. So both are equimolar, so let me take the moles of this one as half and the number of moles of this one as, toluene of toluene is equal to 1.2. Now what is the total pressure here? P total is equal to 160 into 1 by 2, okay, plus 60 into 1 by 2, okay, so that will give me 80 plus 30, that is equal to 110. Total pressure is 110. Now you have to calculate the mole fraction of toluene in the vapor phase, okay, so YT, that will be P of toluene by P total, okay. So what is P of toluene? P naught T into mole fraction of T by P total, okay. So what is P naught of toluene? That is 60, okay, and mole fraction of this one is half, divided by P total is 110, okay. So I will get 30 by 110 or 3 by 11, okay. So I have this one, so I will get 11.2 something. So that is why option number C here. Next, which of the following undergoes hydrolysis most easily? Means hydrolysis means this one is there, okay, and you are reacting it with OH minus, so this one will go and this bond will break, right. So for that, you know, generally the haloarenes do not undergo nucleophilic substitution reaction, but if this ring is electron deficient, okay, it somehow you can make this ring electron deficient, then nucleophile can attack. And how can we make electron deficient? By adding electron withdrawing groups. So I have here 3 electron withdrawing groups, so this makes the ring more electron deficient, and here the nucleophile can attack, so option number D. Next, the compound that can be used as a refrigerant, you may know fluoro-chloro-hydrocarbons or freons are used in that, so option number D. Next, which of the following species can exhibit aromatic character? So for aromatic character, what all things we need? First of all, cyclic structure, sp2 hybridization, and then I need very important 4n plus 2 electrons, and then conjugation, right. So all of them are cyclic, that is there. Now first one, if I see 1, 2, 3, 4, 5, 6, 7, 8. So it is not 4n plus 2, it is 4n electrons. So option number 1 is not there. So whichever options ones are there, I can eliminate that one. Next here if I see 1, 2, 3, 4, 5, 6, yes, that is there, and also I have a positive charge, so sp2 hybridization is there. So 2 will definitely be the answer, so I have both the options 2 and here. I have to see out of 3 and 4. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So this is also again 4n electrons, right. So that is not there. Here we have 6 electrons, so I will have 2 and 3, which is option number D here, okay. Next, which of the following alcohols will hydrate most rapidly when treated with concentrated H2SO4? So in this, when we are treating it with concentrated H2SO4, the dehydration process, okay, dehydration process occurs accordingly 3 degree, 2 degree and 1 degree, right? So here we will have a secondary group, here also we will have a secondary, here we will have a tertiary, here we will have primary, right? So that is why option number C, which is a primary one, which is a tertiary one, will have the maximum reactivity towards dehydration. Next we have the most stable complex. So if you remember that if I have what I'll say chelating ligands, okay, if I have chelating ligands, then they will give, if I have more number of chelating ligands, then I can have what, more stable structure, okay. So I have, you can see more number of chelating ligands are present here, so that is why option number D here. Let us see the next question. The fourth group cations are not precipitated by dilute HCl plus H2S solution. So now you see that because of this H plus present, a very few amount of S2 minus ions will be produced due to the common ion effect, okay. So that is why it is not possible, and the KSP of the sulfide of fourth group are very high, and so we cannot precipitate it. That is why option number B. Next, you have to find X, Y and Z in the following equation. I hope the graph is visible. This is your X, P total. P total is what? Pressure of A plus pressure of B, or pressure of 1 plus pressure of 2. So I have this multiplication here. I can eliminate this one, okay. Next, if you see here, mole fraction, Y is the mole fraction of X2 and it is starting from 0. So X2 will be equal to 0, or I can say Y will be equal to 0. So I can eliminate this option. Now Z is equal to, you already eliminated this option. Now Z, this is your highest point, okay, when the mole fraction is 1. So Z is equal to 1, option number B here, okay. Next, product B of the following reaction, okay. So this is also very simple. Na, NO2 and HCl, you will convert it into N2 plus Cl minus. So what is A here? A will be N2 plus Cl minus, okay. Next, what happens if you treat it with OH group, okay. So we will have OH group like this. You have CH3, N, double bond N and OH, okay. So this we will get here like this, that is CH3 double and this one. So here meta position will not be there because we will have at the para position. So option number B here, okay. Very azodike complex formation. So these were the 45 questions, and I hope all of you have attempted the questions. If you have any doubt in any question, please comment down. I will definitely address to it, okay. So thank you for watching and all the best for your NEET 2025.